Oh, okie, let's get this going. We want to do the parts of a similar triangle. Haven't we done this before? But today you will recognize and use proportional relationships of corresponding angle bisectors, altitudes, and medians of similar triangles, and use the triangle bisector theorem. What does all this mean? It means you got a lot of, theorems to know. So let's look at them. So the first one. If two triangles are similar, the lengths corresponding altitudes are proportional to the lengths corresponding sides. If two triangles are similar, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. If two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. Okie dokie, what does all that mean? It means basically, we've got things called altitudes, medians, and angle bisectors. These are just lines that kind of cut through a triangle. If we know the triangles are similar and we know the sides are proportional, then those lines, whether it be an altitude, a median, or an angle bisector, are also going to be proportional. So let's look at an example, shall we? So here I want to find x. This is an angle bisector. Now, since first off, I'm telling you that ABC is similar to FDG. And since AP and FQ are corresponding angle bisectors, then they are proportional with the triangle. And we got to figure out which sides kind of go together. So in this case, AB and FD go together. So I can quickly set up to say that AP FQ is equal to AB FD. Notice how I did like the left triangle on top and the right triangle on the bottom. Cross multiply, set up your proportions, cross multiply and divide, and you get x equals 10. Fairly simple, not hard to do at all. All right, let's look at another example. Okay, so you can see here, these are altitudes. When they make 90-degree angles, they are altitudes. And these angles are the same. So that kind of tells you what goes to what. So it's not like I'm going to give you extraneous information because I don't need to. That's just stupid. Anyways, so I'm going to say here that Km and Yx are corresponding. And then that MP and YQ are corresponding. So that way I can set up to be 20 over 15 is equal to 16 over x, cross multiply and divide, and then I would get x equals 12. I know, this is pretty simple, right? So it is. I almost forgot one. All right, so here's another theorem. Triangle, angle, bisector. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So now this one is focusing on like this right here, how those sides can be proportional to the sides of the triangle. And we'll look at them as separate triangles. Okay, so we got something like here. Okay, so I need to look at, say, this side right here. Okay, so how do I get that length? Well, the whole thing is 18, and x is that little part, then this would be 18 minus x. So what does that mean? It means if I say, okay, QR, which is going to be 6, I'm going to look at left and right, so QR and SR is going to be proportional to QT, or TQ, and ST. So I can say 6 over 14 is going to be x over x, 18 minus x. Oh no, there's too many x's, I don't know what to do. You'll be fine. Just cross multiply. Okay, so 14 times x is 14x. Okay, so now we got to do 6 times 18 minus x, which is just 6 times 18, which is 108, and 6x. Bring the 6x over. Notice that minus 6x I would have to add. So that gives me 20x equals 108, and divide, and you get 5.4. Easy peasy, right? Let me give you 2 more examples so you can kind of see here. Here, notice that the x is not on that bottom side, and I'm not being given a total here. So I can just go, okay, this one, oops. Let's try that again. There we go. This one I can just say x over 13 is 4 over 6. And then again, just cross multiply. So notice that those two sides that are next to each other on the bottom are part of a separate part of a triangle, whereas those two sides, x and 13, were on another one, and then I just cross multiplied and divide. All right, one final example, and then I'll be done. Here Here's another one that's a minus x one. Notice how I give you a total, and then I give you like a little portion, and you got to subtract. Setup's the same, 11 over 14, x over 20 minus x. Ooh, I almost messed up. Hold up. Okay, so actually I should have had it 20 minus x is with the 11 and x is with the 14. I almost messed up. So when I cross multiply here, I've got 11x is equal to 20 times 14, which is 280, minus 14x. Oops, that's an x. Move that over there. I'm going to add, that gives me 25x is equal to 280, and then I can divide by 25 to get my answer. So, and again, if you want to leave it in decimal form, that is fine. I'm okay with that because fractions are too hard. I don't like the fractions. They're scary. Anyways, if you divide, you should get about 11.2. which would work out nicely. That's for the x, and then you can kind of go from there. Anyways, that is it for today. I'm going to keep this short. Thank you so much for your time. Y'all have been amazing. Y'all take care.